Welcome back, everybody. Today, we are going to be talking about limits. When I'm talking about a limit, I'm talking about when we are approaching some set value. Now, this might be a little bit of a difficult concept, so this is going to be a slightly longer video than normal. So let's go ahead and get started. So what is a limit? Well, a limit is a value that you can approach, but should never actually reach or exceed. Now, on a side note, it's kind of like the speed limit, which you should never go above. So that would be classified as a one-sided limit. Now let's go ahead and take a look at a graph. So if we have this graph, we can see we have this point down here, which we can approach it from the right, and we can approach it from the left. And both sides, as you can see, the function is approaching this setup here. So as x is going to 2, we see that f of x is getting closer to 12. All right. Now, if you actually plug the 2 in, you'll notice that our denominator will come out to be 0, which means we can't actually plug in 2 into our graph and find out what it equals because it doesn't equal anything there. But we can see where it approaches. So that's what the idea of a limit is. You can use it whenever you have to evaluate a function at some point, but it's not evaluatable at that point. Now, we say that a limit exists only when the left limit and the right limit are the same. So if it's approaching 12 from the right, but 10 from the left, well, the limit itself does not actually exist. So let's another graphical example. So let's take a look at the limit as x approaches -5 of f of x and the limit as x approaches -2 of f of x for this graph here. Well, as x approaches -5, we see that it seems to be approaching +4, coming from the right and coming from the left. Therefore, the limit would exist, and it goes to +4. As we're approaching -2, well, from the right, it's heading to 7. From the left, it's heading to 10. So, the limit does not exist. So you will write it as DNE. So here's the first exercise for you to try it out. So find the limit as x approaches 0 of f of x, and the limit as x approaches 2 of f of x for this graph here. So go ahead and pause the video for a moment while you try it out. And once you're done, go ahead and resume. All right, hopefully you've tried this out. So, and I hope you get that the limit as x approaches 0 is about 1.5. And as you approach +2, it should not exist. Now keep that in mind, that is a typo. That should be as x approaches +2. All right. Now there's a nice easy way to calculate limits. So if you consider this function here, and as we're going to x equals 2. Well, we know if you put 2 in directly, it'll just cause a big mess. But we also have to consider from both directions, which can be difficult. So one of the things you can do is write out as you get closer and closer to the value. So this graph here shows our value 2 minus 0.1, minus 0.01, minus 0.001, minus 0.0001, and then we're adding on the other side. So we're taking the limit as we're going from both directions. And then you can evaluate the function at each of these values. And as you can see, on the left side, it's getting really close to 12. And on the right side, it's getting really close to 12. So from there, we can guesstimate that our limit is equal to 12. So let's go ahead and do one of those examples here. So find the limit as x approaches 0 of e to the 2x minus 1 over x. Now, pause And if you need some help, there should be one more step. All right, hopefully you have something down. If not, go ahead and try putting in these values and seeing what you get. So go ahead and pause it now. All right, hopefully you got something that looks like this. Which if you haven't, well, go ahead and see where your arrow was. If you have, then that means that you should have gotten that your limit is equal to 2. Now, sometimes limits don't exist. So consider the limit of 1 over x squared as x approaches 0. Well, we could say that the limit diverges to infinity. Because as you approach from the left and as you approach from the right, it's going up huge. And I put a comma in incorrectly. All right, so if the number keeps getting larger and larger and larger, well, if you say it goes to 100 billion, well, if you get smaller and smaller, you'll probably end up going above that. So in that case, it would diverge to infinity. All right. So go ahead and take a look at this, which it says that does not exist, so I want you to show it. All right, hopefully you've tried it a little bit. Here's this in case you need the values to put in. So go ahead and pause again and try it out. All right, hopefully you've tried that a little bit. And here's what you should be getting. Which for this one, you can see that going negative and positive, which means it does not exist at all.